Hi student, this is Sukumar. 11th standard mathematics chapter number 6, continuation of exercise 6.1. Now problem number 14. Find the points on the locus of the points that are 3 units from x-axis and 5 units from the point 5 comma 1. So look at the diagram. Locus P of h comma 3, point and P dash of h comma minus 3. We have taken h comma 3 and h comma minus 3. The condition given, the locus points are at a distance of 3 units from x-axis. From x-axis 3 units. Here also from x-axis 3 units. Since this line lies below the x-axis, definitely it will be minus 3. But how many units? 3 units. So that I consider the general point as h comma 3. Definitely the y coordinate will be 3. That's a fixed one. Here the y coordinate is minus 3, that's a fixed one. Suppose I consider here 1, what point it is? 1 comma minus 3. If I consider 2, what point it is? 2 comma minus 3. 3 comma minus 3. So the minus 3 is fixed one. Like that here 3 is fixed. At the same time one more condition is given. The locus point is at a distance of 5 units from 5 comma 1. So PQ distance and P dash Q distance always 5 units. By obeying the condition, you have to move the point P and P dash. We have to find out the required points. So what I have given here, since the locus points on this line, which are at a distance of 3 units from x-axis, let them be considered as P of h comma 3 and P dash of h comma minus 3. P of h comma 3 and P dash of h comma minus 3. Now I consider PQ. PQ distance is 5 units. Okay. Given PQ that is equal to 5 units. P we have taken h comma 3 and Q that is given 5 comma 1. So consider them as x1, y1, x2, y2. So distance formula, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Even you can take x1 minus x2 the whole square plus y1 minus y2 the whole square. Same only, both same only. Now you can apply the formula here, x1 minus x2. Even if we take 5 minus h or h minus 5, same only. While squaring, we will be getting same answer. So h minus 5 the whole square plus 3 minus 1 the whole square. That is equal to 5 units. For eliminating the square root, I am squaring on both sides. On squaring. Okay. So automatically the square root will be eliminated. You will be getting only h minus 5 the whole square. 3 minus 1 that is equal to 2. 2 squared is 4. That is equal to, while squaring 5 becomes 25. So I write 5 squared. The next step I write 25. Which implies h minus 5 the whole square that is equal to, this is 25 plus 4 comes right hand side minus 4. So h minus 5 the whole square that is equal to 21. For finding the values of h, taking square root on both sides. So while taking square root, that square will be eliminated, only h minus 5. Definitely have to introduce plus or minus because it's a quadratic equation. We have power 2 and the square root of 21, you can write 21 as it is. It is not a perfect square number. So we need h that is equal to minus 5 comes right hand side plus 5 plus or minus square root of 21. Okay. That means h that is equal to 5 plus root 21 and h that is equal to 5 minus root 21. 5 plus root 21 and 5 minus root 21. Therefore, the required points on the locus are, you can write the result, the required points on the locus, or we consider as h comma 3, p of h comma 3. So h value is 5 plus root 21 comma 3, and another value of h is 5 minus root 21 comma 3. That y coordinate is fixed one. Okay. Also given p dash q also 5 units. P dash q also 5 units. P dash, that is h comma minus 3, q 5 comma 1. P dash equals h comma minus 3 and q, that is equal to 5 comma 1. Now I am going to apply the distance formula. This is h1 y1 and x2 y2. You know the distance formula, square root of x1 minus x2 or x2 minus x1. I consider x1 minus x2 the whole square, that is h minus 5 the whole square plus minus 3 minus 1 the whole square. For eliminating the square root, we have to take square on both sides. On squaring, automatically the square root will be eliminated. In the left hand side, h minus 5 the whole square plus minus 3 minus 1, that is equal to minus 4. Minus 4 the whole square is 16. Then 5 become 5 square because we are squaring on both sides. Right? So I am retaining h minus 5 whole square in the left hand side. This is 25 plus 16 comes right hand side minus 16, which implies h minus 5 the whole square, that is equal to 25 minus 16. So h minus 5 the whole square, which implies 25 minus 16, that is equal to 9. Now we have to take square root on both sides for eliminating the square. Taking square root on both sides, so h minus 5, automatically while taking square root the square will be eliminated. You have only h minus 5. Since we have square in the power, definitely have to introduce plus or minus, and then 9 square root is 3. So h, that is equal to minus 5 comes right hand side plus 5 plus or minus 3. Therefore h, that is equal to 5 plus 3 and h, that is equal to 5 minus 3. Therefore h, that is equal to 8 and h, that is equal to 2. Okay. Therefore the required points on the locus are, okay, listen, look at that, what I mentioned here, p dash of h comma minus 3. Here h value is 8 comma minus 3 and 2 comma minus 3. That's all. So we have 4 required points totally. So problem number 14 is completed. Then I will be teaching problem number 15 in the next video. Thank you, children.